Hello guys, we are here to learn the module number 6, chapter number 6, that is oscillators. And in this oscillator, we are here to discuss the topic RC Phase Shift Oscillators with BJT. So if we want to learn the RC Phase Shift Oscillator, first of all we'll have to learn that why RC Phase Shift and why the term phase shift. So first of all, we want some prerequisite based on the definition of oscillator and the concept of oscillator. So prerequisite is Barkhausen criteria says that AB mod is equal to 1, that is magnitude criteria, and the angle of AB is equal to 360 degree or it is 0 degrees, right? As far as amplifier, CE amplifier is considered, CE amplifier is giving how much degree phase shift? 180 degree phase shift, because we are getting minus sign in the gain. So it's giving 180 degree phase shift, right? So forward block of the complete feedback system is giving me 180 degree phase shift. So how can I achieve 0 degree phase shift or 360 degree phase shift? So either I have to have minus 180 degree phase shift or 180 degree phase shift more in the feedback circuit, right? So I have to design my feedback circuit such that it will give me the value of phase 180 degree or minus 180 degree, right? So that's why the name is phase shift. So basically the required phase shift of 180 degree is given by the feedback circuit, and that's why, and that feedback circuit is obtained by the passive component as R and C. So RC network giving phase shift of 180 degree to form the oscillator criteria of 360 degree. That's why the name is RC phase shift oscillator, right? So this is how the prerequisite is. Now to develop the RC phase shift oscillator, what we'll have to do? So my feedback circuit should give me 180 degree phase shift, right? So I can say that how can I achieve, right, with RC phase shift, right? So I will design my R and C network such that, let's say my RC network is, this is C and this is the resistance R, right? As far as this complete simple network, one circuit network is considered, I can have the output voltage with respect to this input voltage. I am considering only this one RC network, right? So if I am considering one RC network, right, what will be your output with respect to input in the frequency domain? Let's calculate. So in frequency domain, I will first decide what will be your value of the capacitive reactance. So in frequency domain, I will write it in terms of 1 upon SC, and this R will be as it is, that is R. This is VO and this is your value of input VI. Okay, so as far as only this circuit is considered, what I will do, I will just calculate VO divided by VI, and that can be obtained by using, yes, VDR. So we will say by VDR we can have, this is the ratio of R divided by R plus 1 upon SC, right? And this is nothing but RSC divided by RSC plus 1. Okay, I will design my complete this VO divided by VI circuit to get the phase shift of 60 degree, right? So design RC network to get angle is equal to 60 degree, right? If I'm saying that one RC network is giving me 60 degree as your phase shift with respect to output and input, how many RC networks I have to get connected with each other? That is 3. So whenever I'm doing the cascading form, then my gain is nothing but the product and my phase will get added with each other. So if I'm doing the cascading of 3 RC network to form your feedback circuit, then I can say that yes, it is possible to get 180 degree phase shift by using the 3 RC circuit in cascade in nature, and that particular circuit I will use as a feedback circuit, right? So I have got that if each RC network is giving 60 degrees, then if each RC with 60 degree phase shift to obtain 180 degree phase shift, we connect 3 RC network in cascade, right? So that circuit will look like this. This will be your first capacitor, this will be your resistance, this is again second capacitor, this is again a resistor, this is again third capacitor, and this is again a resistor. So this complete circuit will act as feedback circuit, right? All having values same, all resistances and all the capacitances with the same value to get the same phase shift as 60 60 60 and to get the total phase shift as 180 degree, right? So this is how I have achieved to get the RC phase shift oscillator as a circuit as a whole, right? So now we will draw the circuit using BJT, right? Now look at this particular circuit. First of all, I know that this whatever I have formed is familiar to you all, and that is nothing but CE amplifier. Whenever I am considering CE amplifier, it is giving me 180 degree phase shift, and whatever I have drawn after that, that is nothing but your feedback circuit, and that is comprises of RC, RC and this RC. So completely I will be getting the RC network, 3 RC network in cascade to get 180 degree more phase shift. So in all you will be getting 180 plus 180, that is 360 degree phase shift to obtain the circuit as oscillator and to fulfill the Barkhausen criteria. Okay, now as a circuit is considered, that is okay for me, but now there is few findings that we have to obtain. First is frequency of oscillator. That means at what particular frequency I will be getting the particular sinusoidal sustained oscillations. That is nothing but the frequency of oscillations that we have to find out. And what should be the gain factor, that is nothing but to fulfill the magnitude criteria. Okay, so I will say that HFE is how much, right? So basically HFE is the factor for BJT which will decide the value of the gain, because I know that HFE upon HIE into RC is nothing but your gain of the CE amplifier if I'm saying bypass capacitor is used. Okay, so we will take the derivation by using the AC equivalent model. we will draw the AC equivalent model. See guys, here I'm saying that if you have observed carefully, this is R, this is R, this is R dash, it is not R, right? So this R dash is basically the combination of this all resistances and this resistance R that combines your R value. So I can say that this R dash is nothing but R minus this complete resistance. Okay, so what I will use, this is nothing but the combinedly value of R. R dash plus HIE is nothing but the value of R. I am not considering R1, R2 into picture, so not always you have to put this R1 and R2. If I am saying that R1 and R2 is there, then I will keep this over here as well. So what I will do, I will say that here RB is also present if R1 and R2 is present, but ultimately this complete resistance should be having value R. So this is all about with H parameter model. This is the value HIE, and again I'm saying this is not the required part as far as AC analysis is considered, because here I'm not saying that input is given. Input is not given, so all this particular parameter, all these resistances are, I'm taking it at the output side. So along with R dash, if you see, observe this carefully, I can say in AC equivalent model, R dash will be in series with parallel combination of this HIE and this R1 parallel R2, that is nothing but RB, right? So as far as this RB is considered, this complete resistance is nothing but R. Okay, so now I will say that R is equal to R dash plus HIE plus HIE parallel RB. Okay, so R dash plus HIE parallel RB is nothing but the value of R. Okay, fine. So far so well. Whatever we have got it over here, that is nothing but 4 loops, right? If I want to reduce these 4 loops into 3 loops, what I can do? I can do this source transformation. I can say that by source transformation, I can do one thing, that is, this is resistance RC, this is the value, that is HFE IB into RC. Okay, this is the value capacitor, then this is the resistance, this is again capacitor, again resistor, third last capacitor, this is R, this is HIE, and this is the RB, and all are connected to ground. Okay, so this is how our structure is, and this is how we have to move forward for the derivation. Okay, if we take 3 loops, I1, I2 and I3, right, I will get 3 equations, right? So we will say that we will apply the simple KCL over here. We will be getting HFE IB into RC, that is nothing but I1 only, right? So we can say this particular thing will be changed as the voltage source. So simple change that we have to make, as because we are doing the source transformation, current source will be replaced by voltage source. So if we take this mesh analysis, then we'll be getting as, we'll write the first equation by mesh analysis. From mesh analysis will be obtained 2 RC plus 1 upon SC into I2 minus R into I1 minus R into I3, that is equal to 0. That is the first equation I will be getting. The second equation is, I will do HFE IB RC minus I1 into RC minus 1 upon SC into I1 minus R into I1 plus R into I2. So very simple. Okay, so this equation I will modify with taking I1 common and I2 common. Okay, so I will take I1 common, I will take in the form of HFE, IB and RC. I will take this on the right hand side. So whatever data I will be getting in the form of I1, I2 and this constant value. So we will be getting I1, I will take it as a common value. So I1 is equal to I1 into RC plus 1 upon SC plus R. Okay, RC plus 1 upon SC plus R minus R into I2 is equal to minus HFE IB into RC. That will be your equation number 2. Here that was equation number 1. Okay, so the third equation we are going towards to find out, and that will be a simple calculation for I3. Here we will use just host and guest method. You might have studied it in BWE. This will be R plus R dash plus HIE parallel RB into I3 plus, we will say 1 upon SC into I3 and minus R into I2 is equal to 0. Very simple thing. So from these three equations, what we'll have to do? Now first of all, from the second equation, if you observe, I will be getting I1, I2 and IB correlation, right? What is my intention to get? Basically, I have formed all these mesh analysis, I have formed these three equations. My intention to get that to fulfill my Barkhausen criteria. So by definition of oscillator, I can say that A, B should be equal to 1, right? So what I will do, I will find out, let find AI is equal to I3 divided by IB, and that is my intention to get, right? This is BJT, is a current control device, and I want to find out this particular gain as I3 divided by IB, that is nothing but output current divided by input current. So this gain I want to find out. So if you observe these three equations, this second equation is telling me that I1, I2 and IB, right? Third equation giving me the relation between I2 and I3. Now here first step you have to take as keep the value of I2 in the form of I3. So from the third equation, what you will be getting as I2 in the form of I3. From the first equation, you will be getting I1 and I2 in the form of I3. So ultimately what you will be getting, I1 and I2 in the form of I3, and this is how you will be getting the relation between I3 and IB. So let's find out whether we are getting that particular relation or not, right? So what we will be doing, we will saying that alpha is equal to 1 upon omega R into C, and K is equal to RC divided by R, right? I'm not going much in detail about these three equations calculation. It's just a mathematical equation calculation. What we will be doing, omega RC as alpha inverse and K is equal to RC upon R. Now you may get confused that we have used S over here where we will be getting J, where we will be getting omega. So put S is equal to J omega. By putting S is equal to J omega in all 1, 2 and 3 equations and put 4 in 1, 2 and 3, we get what you will be getting. We will be getting I2 is equal to I3 into 2 minus J into alpha. I will keep this as equation number 5. This will be your equation number 4. Then again I will write it as I2 I3 ka relation is done. Then I will be writing I1 is equal to I3 3 minus alpha square minus J4 alpha. This will be equation number 6. Now here what I have done that relation between I2 and I3, relation between I1 and I3, and now I know what is I1 in the form of I3, what is I2 in the form of I3. So ultimately for equation number 2, I will be getting left hand side comprises of the I3 and right hand side as it is we have the equation in the form of IB. So it's very easy to obtain the final expression to have AB is equal to 1 with the gain I3 divided by IB. So I can say that put 5 and 6 in equation 2. If we put 5 and 6 in equation number 2, what we will be getting? We will be getting ratio of I3 to IB, or I can say I3 to IB is equal to minus HFE into K divided by 1 plus 3K minus 5 plus K into alpha square minus J into 6 plus 4K into alpha minus alpha cube. This is what we obtain as a ratio of I3 to IB. As I know that if I am saying I am using this complete circuit as an oscillator, so whatever gain I will be getting, that should not have any phase shift. That means if phase shift is not there, then I can say that whatever I will be getting I3 divided by IB, that should be real. Yes or no? Yes. So I can say that for sustained oscillation, gain is real. If gain is real, then I can say that whatever imaginary part I will be obtaining in the denominator part, that will be 0. So if we equate this part to 0, whatever I will be getting, that will be tending towards the finding of number 1, that is frequency of oscillation. So we will say that at omega is equal to omega 0, gain will be real. So at omega is equal to omega 0, that means omega 0 is nothing but the frequency of oscillation in radian per second. Frequency of oscillation in radian per second. Now omega 0 is nothing but the frequency of oscillation in radian per second. If I am considering the frequency of oscillation in hertz, then that will be f0. So that also I am writing frequency of oscillation in hertz. Okay. Now we have to say that whatever I have got is nothing but A. Okay, whatever I have got is nothing but A. I will treat this as equation number 7. Okay, so we will be saying that whatever things I have got, that is A, AB, and then from equation 7, right, equating imaginary part of denominator to 0, what do I get? That is nothing but 6 plus 4k into alpha minus alpha cube is equal to 0. We'll say that alpha in the bracket 6 plus 4k minus alpha square is equal to 0. As I know that, what is alpha? Alpha is nothing but 1 upon omega RC, right? Where omega is nothing but the frequency, right? So even if practically frequency will not tending towards infinity, so to have alpha is equal to 0, it is not at all possible. So what I will say, as alpha is not equal to 0, I will say that 6 plus 4k is equal to alpha square, right? And now I will say, to opening alpha, so we will say that alpha, what is alpha? Alpha is nothing but omega RC, so omega RC the whole square, rather at omega is equal to omega 0 we are considering, so it will be 1 upon omega 0 RC the whole square is equal to 6 plus 4k. Okay, now here I can say that whatever I will be getting, 1 upon omega 0 RC is equal to under root of 6 plus 4k, right? And omega 0 is equal to 1 upon RC into under root of 6 plus 4k. F0 I can say this will be 2 pi into RC under root of 6 plus 4k. Okay, so this is nothing but your frequency of oscillation for RC phase shift with BJT. So this is nothing but your first finding, frequency of oscillation for RC phase shift with BJT. With BJT is important because if you are considering the FET part, then that will be having some different value. Okay, so F0 is nothing but 1 upon 2 pi RC under root of 6 plus 4k, right? Here we don't have to stop, because we all know that whatever value I have to have with gain, that should also getting satisfied to have sustained oscillations. This is only just the first criteria of your Barkhausen, that is nothing but to get 360-degree phase shift, right? So we'll move towards the next part. Put the value of omega 0, right, and 6 plus 4k into alpha minus alpha cube is equal to 0, right? So equation 7 becomes, how can I say equation 7 is, right? So equation 7 kaise form hoga? That will be, you can say that this will be minus HFE into k divided by 1 plus 3k minus 5 plus k into alpha square. That should be equal to 1, because magnitude criteria of your Barkhausen. So from magnitude criteria, that is AB is equal to 1, right? Now we will put that as alpha square is equal to 6 plus 4k at omega is equal to omega 0. What we'll put? We'll put this particular value of alpha over here with the value alpha square, and then we'll be getting what exact value I will be getting for HFE, that we have to find out. Clear? So that value is nothing but HFE, we get HFE should be greater than or equal to 4k plus 23 plus 29 divided by K. Okay, I will say that where K is equal to RC divided by R. Okay, that is nothing but the another criteria for phase shift oscillator to have sustained oscillation, right? So if we equate this particular thing, then we'll be getting this particular form as HFE should be greater than 4K plus 23 plus 29 divided by K. Now here we have to discuss that what should be the minimum value of HFE that I have to consider. So to take the minimum value of HFE with respect to K, what I will do? Yes, I have to take the maxima minima concept. So what I will do, will say using maxima and minima concept, I will take to find minimum value of HFE DHFE divided by dk. We will take the differentiation for the equation that we have got, that is 4K plus 23 plus 29 divided by K. So whatever we have got, I will write it as a gain criteria. Okay, so we will say that DHFE, so it will become 4 plus 0 minus 29 divided by K square, which is equal to 0. So first derivative should be equal to 0 for as far as maxima minima concept is considered. So we will say that 4 is equal to 29 divided by K square, and this is how we will be getting K is equal to 2.7. So whatever K value we have got as 2.7, and now what we will be doing, for put in equation of gain criteria, right? So what is gain criteria? That is HFE should be greater than 23 plus 29 divided by K plus 4K, right? So just put this particular value of K over here and over here, then whatever value you will be getting, that is nothing but HFE is greater than 44.5. So that should be greater than 44.5. The value which we are getting is 44.5. So as far as the BJT is considered, we all have studied all aspects of the oscillators, all the criterias, frequency as well as gain. So to have the frequency of oscillations is equal to whatever given 1 upon 2 pi RC under root of 6 plus 4K, then you have to have the gain, that is HFE value should be greater than 44.5 and the K value should be 2.7 to have minimum value of HFE, that is 44.5. So stay tuned for further videos for the numerical based on RC Phase Shift Oscillator. Next video we will learn the FET perspective with oscillator, that is RC Phase Shift Oscillator only. So stay tuned for that. Thank you so much for watching this particular video. Subscribe this particular channel of Ekeeda videos. Learn more and more ADC along with me. Thank you.